So, formation of canyons by mega floods. Local ones. Bailey, Forsling, Becraft. Floods accelerated erosion in northern Utah. Now, ongoing. As far as the ordinary smaller materials, sands, silts, clays, are concerned, rivers in flood stage normally excavate their beds to tremendous depths, carrying vast quantities of sediment along in suspension or along the bed to be redeposited downstream when the flood subsides. The action of the great Colorado River of the western United States is not untypical. From the above description, it is clear that when the Colorado River was in flood, it was acting on the solid rock of its bed down to a depth of over 120 feet from the top of the flood river. But that, as the current subsided, it first filled up the inner and deep canyon and then covered the rock platform, thus giving no idea of the violence of its section in depth, where it could flush with great force more than 115 feet of sand-filled cuttings. Without such proofs, few engineers would be inclined to believe that silting follows sand movements down to depths of 50 and 100 feet below normal bed level at each time of a high flood. This is local stuff. Cyrus S. Fox. If this kind of activity occurs during present-day floods, local stuff, what must have been the tremendous quantities of sediment eroded and transported when rain poured forth over all the earth for at least 40 days without stopping? Lest anyone should object that the heavy stands of antediluvian vegetation may have prevented serious erosion by the floodwaters, we cite the following from the Yale conservationist Dr. Paul Sears. He says, "It is often said that deforestation causes floods. This is a half-truth. Water flows faster and in greater amounts off of cleared land than off of forested land, up to a certain point. When rainfall exceeds the critical amount, especially on shallow soils, such as we have in New England, not even forests will hold it back." Paul B. Sears, Natural and Cultural Aspects of Floods. Now we have the destructive power of ocean waves. We looked at local river floods. So we're building up information. What would the worldwide flood be like? Well, here we have evidence that we can look at historically. And it must not be forgotten that the flood damages were due not only to the torrential rains pouring from the skies. There were also great volcanic upheavals, evidently unleashing vast amounts of juvenile waters and creating profound disturbances in all of the Earth's seas and waterways. Great tidal waves undoubtedly were generated in prodigious numbers as the imprisoned waters progressively escaped through crustal fractures all around the Earth, where the fountains of the great deep were broken up. So we have an example. Now we have what could have happened worldwide. Even the action of ordinary waves in littoral coastline currents can, over relatively short periods of time, accomplish tremendous amounts of sedimentary work along coastlines when something happens to change the sediment balance normally existing. Any unusual conditions, whether natural or man-made, may upset the balance in such a way that what has been a very stable beach may quickly show significant erosion or accretion. For example, the hurricanes that at times sweep the Atlantic and Gulf coasts of the United States frequently produce pronounced changes on the affected beaches. This we can examine locally, historically, and then project what would have happened worldwide. This is very short-term stuff. 40 days and 40 nights. Worldwide flood. What would have happened? Obviously, the onset of the Noachian flood would have presented profoundly unusual conditions and would have immediately attacked the antediluvian beaches. And the destructive effect of ordinary storm waves is trivial compared to that of tidal waves and tsunamis, such as must have occurred with great frequency and complexity during the deluge period. Speaking, however, of ordinary waves, King says, now ordinary waves, we're going back from what we can observe historically to projecting what would have happened if all of this happened worldwide. Waves are seldom more than 20 feet high, but violent storms may raise them to 60 feet, and that's nothing in worldwide flood. And there are unverified reports of even greater heights. The immense striking power of a wave cannot be realized until it hits an object that cannot float with it. Waves striking the shore of Tierra del Fuego can be heard for 20 miles. Spray from a storm wave has been hurled to the top of a lighthouse nearly 200 feet above sea level. The force of waves striking the shore can be measured and has been found to reach 3 tons per square foot. Thomas King, Water, New York, 1953. The immense erosive power of such forces should be obvious. Thornbury graphically describes these waves as follows. Waves, particularly storm waves and tsunamis, gigantic tidal waves caused by submarine earthquakes, volcanic eruptions, or slides, and we have historically, this has been reported on TV news, are the most important agents of marine erosion. Smaller waves, such as those associated with surf, may carry on attrition of material and minor amounts of abrasion. But, just as a stream during a single flood may do more geologic work than it will for months or years at a lower water stage, so storm waves during a short period may affect more change than ordinary waves will in months. The enormous force exerted by breaking waves is attested by recorded movements of masses weighing many thousands of pounds. Air in joints and cracks is suddenly compressed and acts as if a wedge were suddenly driven into them. Recession of the water is accompanied by a sudden expansion of air with explosive force. This driving of water into cracks not only exerts great mechanical stress, but insoluble rocks may greatly accelerate solution. W.D. Thornbury, Principles of Geomorphology, get that up there. Okay, good. Willard Bascom, a leading oceanographer, tells of wind-generated waves exceeding 100 feet in height and describes some examples of the immense destructive forces that storm waves can develop. Here it is. I remember this. At Cherbourg, France, a breakwater was composed of large rocks and capped with a wall 20 feet high. Storm waves hurled 7,000-pound stones over the wall and moved 65-ton concrete blocks 60 feet. At Wick, Scotland, the end of the breakwater was capped by an 800-ton block of concrete that was secured to the foundation by iron rods 3.5 inches in diameter. In a great storm in 1872, the designer of the breakwater watched in amazement from a nearby cliff as both cap and foundation, weighing a total of 1,350 tons, were removed as a unit and deposited in the water that the wall was supposed to protect. He rebuilt the structure and added a larger cap weighing 2,600 tons, which was treated similarly by a storm a few years later. There's no end to it. And this is just short-term stuff that's observable and reportable. Again, William Bascom. Probably the most destructive of all waves is that form of tidal wave known as the tsunami. Actually, these are not tidal waves, true tidal waves, although commonly called so, but are caused by submarine earthquakes, volcanic eruptions, or slides. Great worldwide flood. Many of these volcanic eruptions and earthquakes are observed all over the ocean floor, potentially have happened all at once. And when they did, guess what happened? They have been known to attain velocities of 400 or more miles per hour and heights of 130 feet, and to travel extraordinary distances. A small scale of what a worldwide flood would do. Reference, Lewin, Marine Geology, New York, 1950. The Great Krakatoa earthquake, ever heard of that? Of course. In the East Indies, 1883, created immense waves at least 100 feet high and traveling up to 450 miles per hour, inundating neighboring islands and drowning nearly 40,000 people. The tsunami from this quake was still 2 feet high as it passed Ceylon and 9 inches high at Aden, beyond the Arabian Sea. Just take a look at your geographic map. Miles and miles away. In 1946, the tsunami originated in a quake in the Aleutian Island region, traveled 470 miles per hour across the Pacific, creating a 19-foot high tidal wave. Where? The shores of Hawaii, with great destruction. A wave that swept across the bay. No matter not only the height of the wave, but the speed of it. A wave that swept across the Bay of Bengal in 1876 left 200,000 people dead. If history shows us the plausibility of a worldwide flood, and we see stuff all over the world, mountains, tops of mountains, marine life, fossils, and uplifting of mountain ranges. We have mountain ranges underneath the ocean that are huge. Even more recently, tsunamis generated by the destructive Chilean earthquake in 1960 have demonstrated once again the power available in this type of wave. A news account states, the disastrous series of earthquakes that struck Chile late in May has brought death and destruction to countries on the perimeter of the entire Pacific ports from Japan to California and from Alaska to New Zealand. The waves that wrecked the coastal villages of Japan a third of the way around the world were 32 feet high. In both Japan and Hawaii, which was struck by 4 waves, there was serious loss of life and extensive property damage. Chile earthquake. And it is just this most destructive of all types of waves, which must have been produced during the biblical floods by the breaking up of the fountains of the great deep, subterranean caverns of seawater. Furthermore, this breakup, with all its attendant destructiveness, apparently continued from the first day of the flood, Genesis 7:11, through the same period as the great rains from heaven, until both were stopped by God just 150 days later, Genesis 18:2. Also, the fountains of the deep and the floodgates of the sky were closed, and the rain from the sky was restrained. All right, tremendous erosion from the flood's rainfall. Now, we got a picture of local stuff historically reported. Can we just figure the plausibility of whatever would happen if all of these earthquakes and volcanoes that we see evidence all over the world happen maybe at once? We see they evolved, perhaps, or erupted at various times, perhaps if at the same time one would trigger another and another, or one huge event underneath the Earth's surface would do all of this. Bingo! Worldwide flood in nothing. We have the underwater subterranean caverns of waters, and we have the waters above, and the shallow ocean, and we have earthquakes and volcanoes and oceans and subterranean caverns all operating at once. Then we have the waters above, which we would look at that, 180 miles above or whatever it is. I forget, it was, and it's frozen because it's so high up. So if something broke that and the ice came down, because it's super frozen ice, the ice came down